Good morning, everybody.
Good morning, sir.
Good morning.
Namaste.
Good morning, sir.
Good morning. Good morning. So, did you guys get a chance to revise what we did yesterday?
Yes, sir. Sir, even
Yes,
I have
sir.
solved the
The
simultaneous equation.
the two equations. Very good. Very good. Okay. So, we will discuss about those homework questions maybe a little later. Is there anyone who don't know how to solve simultaneous equations using elimination method? You can raise your hand if anyone doesn't know. Okay. So everybody is familiar with that. No one raised.
Familiar with what,
Sorry, Yash.
sir?
I guess you
Could you
were
repeat
trying
the
to say
question?
something.
Could you repeat what you asked?
I guess you were trying to say something, right? I didn't hear you.
No, I was just asking what you asked, that who is familiar with what?
Oh, solving equations. The problems which I gave yesterday. So if you
The
remember, there
equation.
were two. Yeah. So you know how to do that, Yash, correct?
Yes, sir.
Okay, great. Fine. So let's get started now. Sharing my screen. Can you all see my screen?
Yes,
Yes, sir.
Yes,
Okay.
sir.
So let's do a quick recap of what we discussed yesterday. So what is linear programming problem? Can anyone tell me? Yes, anybody can speak up, no problem. Just unmute yourself.
Sir, in this problem, we find optimization of a specific value. That is, we try to maximize it for the best results when there are certain constraints and
Yes,
inequalities that we have to follow.
correct. So basically, we have resources and we are trying to allocate those resources to various activities, and those resources are there is a constraint on the resource. Okay, so we want to ensure what is the best possible way in which we can assign those resources to those activities, and that objective we try to achieve using this linear programming. Anything you want to add to this, Urvi?
No, actually, the same thing. Using minimum resources and making maximum profit.
Okay, fine. Fine. Then we saw one example. What was that example? So company ABC Limited, they are into manufacturing of some glass windows and doors, and they want to revamp their product line because some of their products are not so popular as of today, and they want to replace those products with new products, and these new products are called Astra and Leo. All right, and then some sort of information was provided that there are three plants, and Astra is produced in plant number one because it has some aluminum parts, and then assembled in plant number three. So it uses some sort of capacity from these plants. And the other product, Leo, is produced in second plant because second plant is meant for making wooden things. So it uses wooden parts, and then it is finally assembled in the plant three. And overall capacities which are available in plant 1, 2, 3, spare capacities, I would say, because of stopping some of the existing products were given to us, and we were supposed to find out what is the best possible product mix that we can have. And of course the profit margin was given for each of the product. Okay, and then what we did, basically we converted that whole problem into mathematical terms. So we wrote a objective function. What was our objective function? Z is equal to 3x1 plus 5x2, and Z is what? Z is profit. And what was our objective? Our objective was to maximize the profit. So find out X1 and X2 in such a way that we earn maximum profit, and at the same time we adhere to all the constraints. We don't violate any of the constraints, correct? Then these constraints on the plant capacity, we wrote them as inequalities, and then we started plotting them on the graph paper, right? On a Cartesian plane, we plotted those constraints. There were total 5 constraints. The first 3 constraints, which were related to the plant capacity, I didn't mention this to you yesterday, but we call them as functional constraints. Can you all remember this? Those 3 constraints related to plant capacity, they are called the functional constraints. And the other 2 constraints, I told you some name for the other 2 constraints.
Non-negativity constraints.
Very good, non-negativity constraint, right? So what does
Yes,
that
sir.
non-negativity constraint tells us?
Sir, it means that the value can never be negative, because
Absolutely
obviously the
correct.
products manufactured cannot be negative. It can be 0 or more than that.
Very good, very good. So therefore the non-negativity constraints are also important, and the functional constraints, so they are related to the plant capacity, so they are also equally important. Okay, so we plotted all these constraints, we represented them in terms of line. And why we were able to do that? Because all these equations which are giving you these constraints, we call them function, they were all linear equations, right? So when we plotted them, we ended up having some straight lines, and then we found out a feasible region, okay, where these lines are intersecting, and we were able to locate a feasible region. So we knew that the quantities of X1 and X2, if I pick up anything out of that feasible region, that is going to satisfy our requirement. But then our objective was to find out the maximum profit. So how did we arrive at that? Can somebody explain me what we did with that profit line?
Sir, can I explain?
Yes, Dikshan, go ahead.
Sir, in the profit equation, the left hand side remains same, whatever the right hand side is. So this means that for any value on right hand side, the line will be parallel. So we take
Correct.
any random value,
Correct.
like we took x is equal to 10, and we saw that there
Oh,
is
Z is equal to
more
10.
region.
Z is equal to, hello,
Yes,
Z is equal to 10. Yeah.
And then we saw that there is a feasible region above it, that is Z can be increased. So we
Correct.
made the line up and up till
Correct.
it only touched one point. That was
Very good. Very good. Very good. Okay, I hope everybody is clear about this part. So we call this as a graphical way to understand the linear programming problems. And this is what you guys will have. Those who are in IGCSE, they will have this thing in grade 9, 10. Those who are in state board from Maharashtra, they will have this in grade 11, 12. Not even 11, grade 12. And for rest, I don't know. CBSE, some people were supposed to check, or someone confirmed that it's there. Probably.
I am in IC.
11.
Yeah, Vihan, you're from ICSE, right?
Yeah.
And do you have that in your grade 9, 10 syllabus?
I am not too sure because
Okay.
like ICSE it
Yes, sir.
is a little bit
So in
different. but-
ICSE, we'll have it in grade 10. In IGCSE, we'll have it in grade 9.
Okay. And CBSE, someone confirmed that.
Yes, sir.
it's in grade 11.
CBSE grade 12.
Grade 12, correct. Okay, fine. So you will have only up to this level. What we did until yesterday, a slight addition would be there, which we will be discussing today. But that's it. No, the simplex method you guys will not have. Okay, for 9, 10 or 11, 12. Now, okay. Then I had given you a couple of problems for like equations were there, and I wanted you to solve those equations by eliminating one of the variables, and I'm assuming all of you have done that. Yes, Shriya, any doubt?
Sir, for the plant problem, is
Yeah.
there any way to solve it without linear programming?
Without linear programming, with trial and error, I don't remember name of the student, but somebody tried explaining that using, yeah. Yeah. So basically, just trying out, going logically and trying to solve that. But
Could we
see,
solve that
remember one thing. This problem, as I mentioned even yesterday, the problem in real life are really complex, and they will have lot many variables into that. This problem is very simple, and why we are working with this problem, because we can understand the concept clearly with a smaller version of the problem, and then later on this it can be applied to a bigger complex problem. Okay. Yeah, Kavin, yes.
Actually, this problem I tried by solving without linear programming. Actually,
Okay.
we can solve it with logic, but it won't have any steps. It will be like
Yeah. Correct. Yesterday, someone explained. I don't remember who was that. Was it from batch, your batch, or from the other batch? I don't remember.
Batch A
But
only.
okay.
Actually, it was, I don't remember, but it was like we had to just take the highest possible value of
Yeah.
Leo.
Leo, because Leo is most profitable. So you wanted to make
Yeah.
sure that as much as Leo you want to make. So you figured that out. What is the maximum quantity that we can make, and based on that, he was trying to figure out what's the quantity for Astra. Yeah. So we can do that. Yeah.
I actually did it that way only.
Okay. Yes, Urvi.
I think we can also solve it using linear Diophantine equation with two variables or something like that.
Oh, I'm not.
Because-
I'm not sure about that.
No,
I'm not
in
sure about
linear
Yeah, I think we
Diophantine
can
equations,
solve
we
it.
will get solutions, but we want the greatest possible combination. So
Yeah, then using that we'll get kind of an equation that will be there for which will have solutions for everything, right? Because
yeah,
that's how
but
the
for
We
that
solution
you
can
will have
find
to
out the
solve
profit
all
for
three
all the
equations.
solutions. Yeah, we can find out the profit for the solutions and then we can try.
and then
Yeah.
basically solve all three of them together, the three equations that we get after.
You will
writing
have to, in that case, you will have to solve all the three equations and compare all the values and find out
Yeah,
the
yeah.
best possible combination. That will take
Yeah,
too long.
exactly. But that's just
Okay.
another way we can approach it.
Okay. Yeah. Fine. So now moving on to the next part. Today, of course, those homework questions, if time permit, we will discuss. I'm assuming those questions are easy, so I don't think you guys need any assistance on that. If we get time, we can discuss those towards the end. But what now we are trying to do is the simplex method, which is used for linear programming problems. It's an algebraic way of solving the problem. Okay. But the underlying concept is geometric. Fine. So let's first try to understand that part, and then we will try to move to the algebraic part of that. Okay. So what we are going to discuss today is more or less very similar to what we did yesterday. But yesterday, like we weren't sure about how should I proceed. So we had to draw that profit function line, and then we started moving that line through the region and to figure out what is the final answer. But we are not going to do that now. So let's try to understand what's that logic. Okay. So these are homework question. I'm skipping this slide. That's a problem. Okay. So I'm sure you all are familiar with this diagram, right?
Yes, sir.
Yes, sir.
Yesterday's
The
only.
tomorrow, yesterday's slide.
Yeah, correct.
Can
Good.
you show the simplex
So now,
slide?
sorry.
Simplex method slide. I want to write the definition of it.
Definition of what? Okay, guys. So I will be sharing. I actually share these slides every day after the session. So
Okay.
yeah, you can copy it from there. Fine. Okay. So now, constraint boundary. What do you think? What is constraint boundary? Can somebody explain? These are very.
Sir, the boundaries
Can I?
which bind the feasible region.
Yes,
Boundary which binds the feasible region. Okay.
Or
Everybody agree with this?
yes.
yeah, but
Sir-
we can say that a boundary, constraint boundary is like
a boundary in which we take any value from that, like as Vihan said, it is the boundary of a feasible region. And
Okay.
if we take any value from that feasible region, that will satisfy all our constraints that we have mentioned.
Okay,
A
fine.
solution.
Okay, okay, okay. So
Sir,
let's think.
sometimes
Yeah.
the constraint boundary will also consist of the solution. So it doesn't bind the solution. It itself can contain some of the solutions.
Okay, fine. So let's try to look at this. Let's try to look at this. X1 less than equal to 4. Okay, so what we did, we first drew a line for X1 is equal to 4. Which one is that line? We see that this line, right? We see here this line, correct?
Yeah.
So this entire line we can call that as constraint boundary. Okay, which is for this first constraint, X1 less than equal to 4. Are you all understanding this?
Yes, sir.
Similarly,
Yeah.
for
Sir.
2 less than equal to 12, oh, this is the constraint boundary. Okay, this is the constraint boundary. So these are all constraint boundaries. Okay, it may be in the feasible region, it may not be in the feasible region, but these are all constraint boundaries. Okay, now the next point, corner point solution. What do you think? What do you understand by corner point solution?
So we have to try
It
the
is the
First of
corner point.
edges.
It's two
all, tell
two
me what is
commas.
corner point. First of all, tell me what is a corner point in this.
Extreme point on the boundary, like 0, 6, 2, 6, 4, 3, and all.
Correct. So can we say that corner point is a point where two constraint boundaries meet each other?
Yes.
Yeah.
Yes,
Yes,
sir.
Yeah, you all agree. So for example, let's look
Intersection.
at this. Is it a intersection of any or two constraints constraint
Yeah.
boundaries?
Yes.
Which two constraints?
Negativity
The
constraint.
non-negativity.
Non-negativity constraint. Very
constraints.
good. So x1 has to be greater than equal to 0, x2 has to be greater than equal to 0. These two lines meet up here and we get a corner point. Same way, what is this a constraint? Is this a corner point?
Yes.
It is
Yeah, it's
x2
the-
constraint and
Yeah,
So
non-negativity
x2
X2
less
constraint.
is
than equal to
greater or
12.
equal to 0.
Correct.
And
What about this? What about this? Is this also a corner point?
so which one?
0,
But
9,
it's not
0.
in the feasible, not
Yeah,
surrounding the
okay.
feasible
Yeah, but
region.
it is a corner
My question
point.
is simple. Is it a corner point?
Yes.
Yes.
It is a corner point because it is at the
is.
intersection of the two constraint boundaries. Correct? Okay. So how
Yeah.
many corner points are there? Can somebody count and tell me total how many corner points are there in this case?
8.
8.
Okay, let's do the counting. 1,
Eight.
2, 3, 4, 5, 6,
eight.
7, and
Seven.
8. Right?
8.
Okay. Now we put them in two buckets. Okay, we say some of the corner points give us feasible solutions and some gives us infeasible solution. I think the name itself is making sense. So
Yes,
if
sir.
I talk about this point 0, 9, it's a corner point solution, right? It's a corner point solution, but then it's infeasible
It's
solution.
infeasible.
Why? Because it is outside our feasible region. Are you all with me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good. So
There are
now,
3 infeasible.
so let me write down quickly. Infeasible solutions 0, 9, then
4, 6,
4, 6,
And 6,
6,
0.
0.
and 6, 0. Correct. Right. These are infeasible solutions. Whereas feasible solutions, I'm not going to write that. I'll just put a circle around that. 0, 0, 0, 6, 2, 6,
4-0.
4, 3, and 4, 0. Right. So we can divide these corner point solutions into two buckets. One is feasible solutions and infeasible solution. Okay, so we'll be using this word maybe quite often. CPF solution, corner point feasible solution, right? So what we are interested in, corner point feasible solution. These are of no use for us, right? I hope you all agree with me, correct?
Yes,
So we
sir.
are only interested in CPF solution. Okay, now what we want to know is adjacent CPF solution. What do you think? What is adjacent CPF solution?
One next.
The one that lie on the line.
One
Right.
each
So let's
next
take an
to each
example. Let's take an example. If I am talking about corner point feasible solution 0, 0, then which one is the adjacent solutions of this?
4, 0, and 0, 6.
Very good. 40 and 06. Everybody agree with that?
Yes.
Yes,
Yeah.
sir.
Okay, very nice. If
Yes,
I'm talking
sir.
about, let's say 43, what is the adjacent CPF solution?
40,
26 and
46,
40.
60.
Very good.
Sir, even
40,
60.
No,
60.
40
Okay.
and 26.
It's an
But we are talking
invisible
about, hello, we are
solution.
talking about CPF, corner
Oh,
point
okay.
feasible
Yeah.
solution, right?
Okay.
So I can't consider 60. Okay.
60 and 46 are
Yeah.
invisible.
Yes. Okay. Now,
Sir,
what we saw. Yes, Anahita.
sir, actually I left for a minute or so. So can you just explain that adjacent CPF solutions once again?
Yeah. Okay. So CPF stands for corner point feasible solution. So if we start with this solution, which is a CPF solution, right? 0, 0. And if I ask you what is the adjacent CPF solution of 0, 0, so you will start looking at the boundaries which are coming out from this point. So there are two boundaries coming out, this one and this one. And then you start moving until it hits the next boundary. So the next boundary is hitting this boundary at this junction. And this point 4,0 is the adjacent corner point feasible solution or adjacent CPF of 0, 0. Same way, if I move along the boundary in this direction, I'm hitting the next boundary, constraint boundary at this point 0,6. So 0,6 becomes the another adjacent CPF for 0, 0. Is it clear to you now?
Yes, sir. Thank you.
Okay, fine. Now, tell me one thing. In this feasible region, how many points would be there inside the feasible region?
Infinite.
Infinite. Absolutely correct, right? So, if somebody wants to, and can I say all of them are like all of them can satisfy all these constraints, all these
Yes,
constraints,
Yes.
right?
sir.
Okay. So if the dumbest person, if you think of a dumbest person and he wants to find out the maximum Z, so he might want to start with picking some values out of this feasible region and start calculating Z for each one of them. Okay. But that's a foolish task, right? That does not make any sense. What we observed yesterday is when you start moving the profit function line through this region, it is going to give you optimum result whenever it is going to hit one of the corners. You all agree with that?
Yes.
Yeah.
Yes, sir.
Sir, but not any of the corners, like towards.
Any one corner. Okay, anyone. We don't know which one. Could be any one corner, right?
Yes.
Yeah. So now, then instead of calculating several values, don't you think it makes sense to just focus on the corner points and calculate the value of Z for those corner points?
Yes, sir.
Definitely. Because
Yes.
that's
Someone mentioned that yesterday as well. Okay, someone mentioned that yesterday. So that's the approach is used in Simplex. Okay, rather than focusing on too many values of x1 and x2, we try to focus on the corner point solutions. Okay. Yes, Urvi.
So there will also it might also be a case that the line is parallel to one of the boundary lines. So then we'll get like a line of solutions.
Multiple.
So
Then there are
corner
multiple
point
possibilities.
solutions. Yeah, two corner point solutions.
Correct. So and then there could be multiple solutions possible, right? Someone was asking me yesterday, is it possible that the line is not hitting only one point but more than one? Yes, that's possible, and in that case you may have multiple possibilities. Okay, multiple solutions giving the same value of Z. Okay. Yes. So now, what is the optimality test? See, our objective is to achieve the optimum solution, right? So what is the optimality test? So what are we going to do is we are going to evaluate Z values at each corner. Okay. And if so, let's read this statement. If a CPF, that is corner point feasible solution, has no adjacent CPF solution that is better or that are better, then it must be an optimal solution. So are you guys understanding this? I start evaluating the corner point feasible solutions, and when I'm doing that, I will evaluate the adjacent CPF. If the adjacent CPF is not better or are not better than this, then this is the optimal solution. Okay, that's the optimality test. Now let's try to understand this. We'll run through this. This is the algorithm basically, which is used by Simplex. What is that algorithm? So first step is it's an iterative algorithm or iterative algorithm. What does that mean? We run that algorithm again and again until we get our solution. Fine.
Sir,
So what is yes.
sir, can you please explain optimality test once again?
Yeah, sure. See, what is the optimality test telling is that when you are evaluating a corner point solution, let's say we are here, okay, at this point, then what are the adjacent CPF to 2 and 6? 0, 6 and 4, 3. Okay, so while you are analyzing this, you will find out the Z value for the adjacent CPF. And if both the Z values of adjacent CPF are lower than the Z value for 2, 6, then we say this is the optimal solution. Okay,
sir.
so we will run through this algorithm step by step, and it will make sense. Okay, so first step is yes, Kavinayan.
Sir, if the other thing is higher, then we should go to the next adjacent.
Yes, then you should go to the next one, and that's what this iterative algorithm means. Okay, we perform these steps again and again. So first step is initialization. So basically finding the initial corner point feasible solution. I'll talk about it a little later when we move on to the next slide. What should be the initial CPF? Okay, then once we select an initial CPF, we perform optimality test on that. If that solution is optimal, or we stop. If it is optimal, is the current CPF solution optimal? The answer is yes, we stop there. If the answer is no, we again move to the next iteration. Fine, and then we perform iteration to find a better CPF solution. That's the algorithm which runs in Simplex method. Okay, now let's try to understand this using our example. So okay, fine. Now what was the first step? Initialization. Okay, so how many CPF are there in this problem? How many CPF are there?
5.
5. Okay,
5.
Out of that, one I am going to select as my initial solution. Okay, initial CPF. Now as a rule in Simplex, always we start with 0, 0 origin. The simple reason, I don't need to do any calculation. Okay, when I'm selecting this as my starting step, I don't need to calculate. What is the Z value at this point?
0.
0, right? Because x1 is 0, x2 is 0. So what profit are you going to make? The profit will be 0. Correct? So yes, Anaita.
Yes, sir. So just a doubt that why do we start from 0, 0 when we know that there are more greater values there out there?
Exactly. Yes. So the reason is very simple. I do not want to do any calculation for the first step. Everything is readily available, and this will make a lot of sense when we actually move on to the Simplex method. Okay. So I start with the first step where I'm saying the initial stage, I'm starting from this point 0, 0. Okay, and then what do we do? The next step, we check, is this an optimal solution? Is this an optimal solution? Oh, to know that, first I need to calculate what is the Z at this point. So Z at 0, 0 is equal to 0, right? You all agree? Z at point 0, 0 is 0. Okay, now the question is this an optimal solution? The answer is obviously no, because we know when we increase the value of x1 and x2, Z is going to increase. So this is definitely not an optimal solution. So in this algorithm, is this an optimal solution? The answer is no. Then the next iteration, what do we do in that? Perform an iteration to find a better CPF solution. So how do we find out a better CPF solution? From this corner point, what are the two possibilities? What are the two adjacent CPF? Either I can move in this direction or to hit this corner point solution, or I can move in this direction to hit this corner point solution. Now, when I look at the rate of improvement of Z, the rate of improvement is 5 when I increase quantity of X2 by 1, whereas rate of improvement in profit is 3 when I increase one quantity of X1. So which one would you like to go first? Which one will give you better profit?
0.6.
0.6.
Yeah, you should try to increase the quantity of X2, right? And that means I know which direction I have to move. So I move to the direction of 0.6, correct? So that's the third step. That's the third step. Perform an iteration to find a better CPF solution. So which is a better CPF here? 0.6, right? Better CPF is 0.6. 0.6. So I figured out the better CPF. Okay, now again, we are back to the same. So this becomes my initial solution. Okay, now 0.6 is something which I'm trying to evaluate. So the very first thing I'm going to do, I will calculate what is the profit at 0.6. What is the Z value? Okay, so that's going to be
30.
X1 is 0. So that's 3 times 0 plus 5 times 6, which is equal to 30, right? So Z value at 0.6 is 30. Okay, what's the next step? Is this solution optimal? Okay, is this solution optimal? What do we check in optimality test? We look at the adjacent CPF. Now, what are the adjacent CPF of 0.6? Tell me.
0, 0 and 2.6.
0, 0 and 2.6. Does it make sense to go in the direction of 0, 0?
No, because we have already checked.
We are going down and the Z value will go down. So the only available option with me is I can think about this solution. And is this solution better than this? The answer is yes.
We have to check.
Why? Because X2 value is still same, but then we are adding some X1s into that. And if I am adding some X1, the profit will go up, correct? So we say, which is a better CPF? The better CPF is 2.6, right? Okay, very good. So now the next iteration. Okay, so I go to the next step, which is 2.6, and first thing I calculate what is the Z value for 2.6. Yeah, yes. So 3 times 2 plus 5 times 6, that's equal to 36. Okay, then what is this an optimal solution? Oh, I need to check that. So for that, I will have to check the CPF, adjacent CPF. So what are the adjacent CPF of 2.6?
0.6 and
0.6 and 4.3.
We need to check.
Does it make sense to go to 0.6?
is
No, we already checked.
No, we already checked that, and 2.6 is better than 0.6, so we are not going to go there. So what we need to check is 4.3. So at 4.3, what is going to be the profit? Z at 4.3, sorry. Z at 4.3 is 3 times 4
27.
5 times 3, which is 12, and 15, which is 27.
27.
Okay, so Z at 4.3 is not better than Z at 2.6. What does that mean? We have reached a corner point where both the adjacent CPFs are worse than this, right? So we conclude that this is the optimal solution. Have you all understood this method?
Yes, sir.
Yes.
So, and is it
You
true
told that this method is
one by one. Yes, Kavin, go ahead.
So should we always start from 0.0?
Yes, that makes a lot of sense because you don't need to do any sort of calculation. And as I said, you will realize why I am emphasizing was this when we move to the simplex method, actual simplex method. Okay.
But what if 0.0 is not a flexible point?
What if it is not in the feasible region? Correct. So I would say that is a little bit of advanced stage. If we get time, we will discuss about that. Okay. So in that, see, there is no harm in starting from any other point. Okay. There is no harm in starting from any other point and then following the algorithm. It's going to work perfectly fine. So if you want to start with 4.0 or let's say 4.3, you can still do that. That is not going to give you wrong results. Maybe the number of steps could be sometimes it could be little higher. That's it. Okay. Yeah, fine. Any other question from anyone? Some people have
Not a
raised hand.
question, but for what he said, say the
Yeah.
non-negativity constraints are not 0, but something like 1 or something, then we can still start from the smallest possible.
Smallest possible value. Yes, that makes sense. Yes. So if you,
So-
if 1 is the point which is falling on the feasible region, then you can start from that point. Yeah.
So I have a
Okay.
doubt.
Yes, Vihan.
So we always start from the corners only, right? So
Yes.
basically, like the best like CPF will be at its corners, right? We don't need to
Yeah.
check in the center.
Yes, yes, yes. And why are you convinced with the reason why are we doing that?
Yeah,
if I
because it's like
yeah, you know
the
that,
limit.
correct. Because if I, let's say if I select this point, okay, and I know my profit function is something like this. This is the line of my profit function, and whatever profit value I'm going to get, I know as I move this line away from the origin through this region, the profit is going to increase because I know these parallel lines, the right hand side of this will be higher as compared to the right hand side of this, correct? And that's the reason I don't care about the points which are inside the feasible region. I really don't care about that. I just focus on the corner points. Okay, fine. Good. So are you all clear with the simplex algorithm? So this same algorithm will be followed when we move on to the simplex method. Are you all clear about that?
I have a question.
Yes, sir. I have
Okay.
a doubt.
Yeah, go ahead.
Yeah, even I have.
Yeah, go
Okay,
ahead. Go ahead.
Purvi, you go ahead first.
Yeah, Anaita, go ahead.
Okay, sir. So just a doubt that I had a doubt which was similar to that of Vihan, like why
Yeah.
can't we just start from a different point than 0? And I
Okay.
have another question which is
Yeah.
not yet clear. Why do we have
Mhm.
to start from the smallest point when we know that we have to maximize the profit? Why can't we take a random point, say in the middle of the graph, which we know will be obviously higher than 0,0, or any number on the y or the x-axis?
Correct. So that, see, as I said, even if you start from any of the point, finally you will arrive at the same solution. So it doesn't matter really from which point you are starting. But as I said, you will understand the importance of starting from 0 when we reach to the simplex method. Okay. Okay. So till that time, maybe you can hold this question, and I hope this will be automatically answered when we move to that last stage. Yeah.
Okay. Sir.
Yes,
Thank you.
Anaita. And that's it. Okay. Yes, Urvi.
Yeah. Also, like I did not understand how this algorithm of like, let's say that this is one point, we choose any random point, and then we take the adjacent ones and compare it. There might be a case that the point we choose is slightly more than the ones that are adjacent, but then there is another point that is the maximum, which is even more than this. So we won't even like know about it. According to our algorithm, we just continue and make this as the maximum one. But
yeah, so what I would suggest is maybe whenever you have free time, just try to think of some example where you feel that this could be possible, and then you can share that with me and we can discuss about that.
Okay.
Yeah. Okay, fine. Now having gone through this geometrical concept where we have some kind of shape and we are trying to move along the corner points which are created by intersection of the boundaries, okay, and trying to understand the algorithm of simplex method, the next stage would be to move to the algebraic way of thinking. Okay, so and see this, as I said, these problems, real problems, are extremely hard and very complex. So the geometric way of solving this problem is not going to work, or rather I would say when it comes to computer, the computer would understand the algebraic language better than the geometric. So these problems are solved in computer using algebraic equations. Okay, So we are also trying to now switch from this geometrical way to the algebraic way. But during this journey, there are certain other points which we need to understand. So we are now going to focus on those concepts which will help us to understand the algebraic way of simplex. Okay, so let's move on to those things. We have discussed about this, so I'm not going to talk about it now. Okay, how many of you are familiar with matrix in mathematics? Yes, Kavinen, you know what is matrix. Okay, Samyak, Purvi, fine.
I know
So
the basics only.
you know the basics. Okay, Neil, okay, Smayan. Okay, can someone tell me what is a matrix?
So it's a collection of numbers, and we can
It's a
perform
collection of
certain
numbers.
operations.
It's in a brackets.
In a brackets. Okay, so it's a collection of numbers in a bracket. So yes, it's arranged, it's an array of numbers, right? So the array of number means basically arrangement of numbers in rows and columns, right? Arrangement of numbers in rows and columns. Okay, fine. So you guys know, and those who, sorry, yes, somebody was trying to say something. I don't know. Kavi,
So
who
they
was
are
trying to-
arranged in rows and columns, and the numbers are called elements.
Yeah, the numbers are called elements. Okay, anything else? Anybody want to
Sir,
add?
we use matrix to solve linear equation in 3 variables.
Linear equations with 3 variables. Okay, good. And you know how to do that?
No, sir. I just know. If we know complete matrix, we are able to do. But I know only the half or part.
Okay, fine, no problem. Other people who had raised hand that they saying that they know the matrix. What do you know anything more about matrix other than the what it is, and it has elements and the numbers are arranged in rows and columns? Do you know anything more about matrix?
Sir, it is classified into different types like square matrix, rectangular matrix.
Okay, the types of matrix. Okay, good.
The multiplication of matrices.
Multiplication of matrices. Okay,
And
okay, fine.
transpose of a matrix. Like
Transpose of a matrix. Okay, fine. Okay, so let's try to understand this. Since everybody is not familiar with matrix, let's try to understand this, and let's try to see how we can use this. Okay, so I'm taking a very simple example. Say, let's say Ajay has, say, 3 pencils and say 2 erasers. Okay, maybe say Vijay has 5 pencils and say 7 erasers. Okay, so if I want to show this information in the matrix form, maybe I can try to show something like this. For Ajay, these numbers are 3, 2, and for Vijay, these numbers are 5, 7. Okay, so the first row is giving me information about the pencils, how many pencils are there. The second, the first column. The second column is telling me about how many erasers are there. The first row is telling me, okay, giving me information about what Ajay is having. The second row is giving me information about what Vijay is having. Okay, so this thing is called a matrix. This
Sir,
thing is called, yes.
just a confirmation. By any chance, are determinants related to this?
Yes.
Okay.
Determinants are related to this. Okay, now there is something called as order of matrix. So
it is product of rows and column, number of rows and columns.
Correct. So this order of matrix basically talks about number of rows times number of columns. So in this matrix, how many rows are there? This
2.
matrix, 2. And how many columns are there?
2.
2. So we say order of this matrix is 2 by 2. Okay, so this is a matrix of order 2 by 2. Okay, if I ask you, okay, there is a matrix of order, say 2 by 3. What does that mean? It is going to have how
2
many
rows
rows?
and 3 columns.
Very good.
Pencil, eraser, and sharpener.
So yeah, maybe we add another element to that. So let's say 2, 4, 7, and maybe 5, 1, 3. So it has got 2 rows and 3 columns. Okay. Then a matrix could be a square matrix. What do you understand by square matrix logically?
Equal rows and columns.
Very good. So 2 by 2, this is a square matrix. Okay, it could be a rectangular matrix as well. What do you understand by that?
Number of rows and columns differ.
Differ.
Yes, like
So
2 by
can I
3.
say 2 by 3 is a rectangular matrix?
Yeah.
Yeah. Okay. Fine. And another point which I want all of you to understand is there is something called as identity matrix, and it is denoted by letter I. Okay, letter I. So what is an identity matrix? It's a matrix with all elements 0 except
Diagonal.
the diagonal elements which are 1. For example, let's think about a 2 by 2 matrix. Okay. So in a 2 by 2 matrix, the diagonal elements are 1, all other elements are 0. This is called an identity matrix. Okay. Let's
We
think.
can consider that 0, 0 is also a diagonal.
Yes, but this has been defined like this.
The matrix
You
only
start
left
from,
to right.
yeah,
From-
from left to right. The diagonal that we are considering is from left top corner to the right bottom corner. Okay. If I'm thinking about 3 by 3 identity matrix, then 1, 1, 1. This diagonal will have 1. All other elements are going to be 0.
What if it is a rectangular matrix?
So identity matrix is defined only for square matrix.
Okay.
Okay.
And the numbers are always
Formed
1
only
and
in
0.
square matrix.
Sorry, one person at a time. Yes.
So the
Yes.
numbers are always 1 and 0.
Yes. Specific to identity matrix we are talking about. This is a special kind of matrix. Okay. So in identity matrix, the diagonal numbers are 1 and the other elements are 0. Okay. Yes, Shriya.
Always.
Sir, I didn't actually quite understand the identity matrix.
Okay. So identity matrix is a matrix which is having the diagonal element as 1 and all other elements as 0. For example, if I look at the 2 by 2 matrix, the diagonal element, these are diagonal elements. These are 1 and the other elements are 0. When I'm talking about 3 by 3 matrix, these diagonal elements are 1, but all other elements are 0. Is it making sense, Shriya?
Yes, sir. Thank you, sir. Sir, also, can
Yeah.
it be like the other diagonal?
No, it has been defined like this. It can be, but
Okay.
then when we talk about identity matrix, you have to think of this diagonal. Okay. Okay, Neil. Yes.
Sir, 1 minute, I'll read this.
Sir,
I'll
in
write
the
this.
Okay.
identity
Oh, you-
matrix,
Yeah. Sorry.
the identity matrix, it can't be like the diagonal is 0, 0, 0, right?
No, when we are talking, you can have a matrix with all elements 0. Okay. That is called a null matrix. All
Okay.
elements 0. So anything is possible, right? Matrix is just arrangement of numbers. So inside that you can have any kind of numbers. But
So-
we are focusing on a special kind of matrix which is called identity matrix, which is having this kind of arrangement.
So,
Clear?
sir, in an identity matrix, everything can be 1 also. What is that called?
No. If everything is 1, then like all elements are 1, we cannot call that as an identity matrix. That's not an identity matrix. Identity
And-
matrix will have diagonal element 1, everything else 0.
So
Oh, okay.
Okay. Yes.
yeah, so basically in an identity matrix, can both the diagonals be 1, 1?
No. Only one diagonal starting from left hand side top corner to the right hand side bottom corner.
Okay. So what's the importance of this?
You will realize that very soon. Okay, just hold on for some time. Yes, Anaita.
I actually had to ask the same doubt. What's the importance? But
We will learn that. We'll learn that. Don't worry.
and another
Yes.
doubt is that you said any kind of numbers will do. So will negative numbers also hold a place here?
Yes. Negative or let's say fractions, anything you can put.
Irrational will also do.
Yes, it holds a
Okay.
number. Okay, it can be any number. Yes, yes, Varun.
Imaginary numbers.
Yes, no problem with that.
Sir,
Yes, Varun.
identity matrix is only applicable for the square matrix.
Yes, only for square matrix. You're right.
Okay.
Yes, Aniket.
So can we have any other number than 1 for the identity matrix?
Not in the identity matrix. When we say identity matrix, the diagonal number has to be 1.
Okay.
Okay. Yes, Parul.
Sir, taking the case of Ajay, Vijay, the pencils thing.
Yeah.
If you add another element only to Ajay, say for sharpeners or something.
Yeah, and Vijay does not have any sharpener, right?
So
So for him, you can show 0.
Oh, okay. So
Correct.
it has to be like a proper grid. You can't miss out any part. Like
Yeah, of course, you can't miss any element. So either if he has that element, you write that value. If he doesn't have, you write 0.
Okay. Yes.
Right. Okay. Fine. So now let's move on, and there's something called as elementary row operations. Okay, this is very important, and you guys will learn this in grade 12 probably. Okay. So what are the elementary row operations? Maybe you guys should start writing these things along with me, and you should practice these things because we need to use these things while solving our problem of LPP. Okay. So now, R stands for row, right? Our matrix is made up of rows and columns. Fine. So R stands for row, and I stands for the number of element. I and J, you know that small I and J stands for number, the element number. So there are 3 types of transformations that we generally use on matrix. Okay, so the first one, Ri, and notice carefully that this line has arrow in both ends. Okay, so Ri and Rj. What does that mean? We are swapping 2 rows. For example, let's say we have a matrix like this.
Sir, what was I and J?
1 minute. You will understand now. 2, 4, 5. Let's say 1, 7, 3, and maybe say what 4, 9, and 10. Okay, this is our matrix. So what is row number 1? What elements are there? Row number 1.
2, 4, 5.
Very good.
2,
Row
4,
number
5.
2. Row number 2.
1, 7, 3.
And row number 3. Row number 3.
4, 9, 10.
Very good. So if I tell you, we are going to do this transformation. Row 1 swap with row 2. What does that mean? This matrix
173 will go to the first row.
4, 5, 4, 9, 10.
right? We are swapping these 2 rows. So second row will become first row will become second row. So 173 will come on the top. 2, 4, 5 will become the second row. Have we done anything with row 3? No. So row 3 will stay as it is. Okay? Stay as it is. Right. So this is the first transformation. Okay. Yes, Shriya.
Sir, actually the audio wasn't coming for me for like 1 minute in between. So can
Okay.
you explain what Ri and Rj is?
Yes. So the I and J stands for the row numbers. So for example, here we are saying R1 swap with R2. So row 1 and row 2. So I is 1, J is 2. They are just letters we are using for denoting numbers. That's it. Okay. So
Yes, sir. Thank you, sir.
yeah. Second transformation. Okay, so Ri, now remember this line has just an arrow on the right hand side. Okay, I'm transforming Ri by multiplying it with some constant. Okay, where k is not equal to 0. Fine, we will stick to this matrix only. Okay, and let's say I want to perform this operation, say R2, I'm going to multiply this with say 2. So what does that mean? Please remember, I'm sticking to this original matrix and trying to perform this operation. So
second row will come as 2, 14, 6.
Yeah. 1 minute. So let's go step by step. Are we changing anything in row 1?
No.
With this transformation, are we changing anything in row 1? No. So the row 1 will stay as it is. So write down that as it is. Are we changing anything with row 2?
Yes.
The
But
answer is yes.
row should be 173 because we have already performed the operation.
So I'm saying this is my original matrix and I'm trying to perform all the operation. You want to continue from here, we can do that. But I'm saying just stick to this one. Okay. Yeah. Okay. So second row, what I'm doing, I'm multiplying every element by 2. Correct. So if I multiply 1 by 2, I'm going to get 2. If I multiply 7 by 2, I get 14. If I multiply 3 by 2, I get 6. Are we doing anything with row 3?
Nothing.
Nothing. So the row 3 will stay as it is. Okay, this is the second transformation. Okay, this k, instead of multiplying by 2, that this k can also be a fraction. For example, if I tell you that R2 is 1 by 2 into R2, what does that mean actually? We are multiplying by half. That means, in fact, we are dividing by 2. Are you guys understanding this? So
Yes.
even though in a rule it is shown as multiplication, but that multiplication you can use even as division. Clear?
Yes, sir.
Okay. Yes, Kavin.
Sir, if k was 1, there won't be any change.
Any
in
change?
row
Then
2.
that step does not make any sense, right?
But
You're doing
should we
nothing.
consider it as a transformation?
If you are taking k as 1, then you are not transforming that matrix. You will ultimately get the same thing back, right?
Yes,
okay.
sir.
Now the third transformation. 1 minute. Okay. So the third transformation is this. Again, okay, let me write down this matrix again so that there is no confusion. 2, 4, 5, 1, 7, 3, 4, 9, 10. Okay, let's think about the third transformation. So we say Ri is equal to Ri plus k times Rj, and again where k is not equal to 0. Okay, let's take some example to understand this.
Can
Let's
it be
say
only plus k?
Okay, I'll come to that point. It can be minus as well. I'll come to that point. 1 minute. So let's say let's do something with row 3. We haven't touched row 3 yet. So let's say I want to modify row 3, and I want to make this element 0. Okay, I want to make this element 0. 4, I want to make this 0. So what should I do? If I subtract 4 from this, I'm going to get 0, right? But how am I going to do that? Row 3 minus.
Keep k as 1 and then Ri as minus.
So we have
Minus
1
2
already
into
here, right?
row 1. Minus
So
2
if
into
I
row 1.
multiply this row by 4 times R2. Okay, this transformation I'm trying to do. Now, what am I going to get? Are we changing anything in row 1?
No.
No. So row 1 you can safely write as it is. Are we changing anything in row 2?
No.
No,
No,
sir.
so row 2
Using
also
it
you
in the
can write.
transformation, not changing.
Correct. Are we transforming row 3? The answer
Yes.
is yes.
Yeah.
Yes.
Now let's write down those steps
So just a
separate. Yes. Write down those steps.
in the top, you wrote
yes.
Ri is equal to Ri plus KRJ.
K times
But
RJ.
here
Yes.
you give minus.
Okay. So let me
Minus
do.
4.
Is it okay now?
Okay, so if we're
I'm
considering
adding
that
it, but
to be
I'm
minus
multiplying by -4. So this is same as subtracting 4 times R2, right? Clear?
Yes.
Okay. Now let's think about each element. What's going to happen with 4? I'm going to write R3. My new R3 is going to be the original R3, which is 4. I'm just focusing on this element, okay? Plus -4 times corresponding element from row 2. What is the corresponding element from row 2? 1. Very good. 1.
So 1.
Okay. So what value are you going to get here now?
0.
4 into -4 into 1 is -4. So 4 minus 4, which is going to give me 0, right?
Yes,
Okay.
sir.
Let's think about the second element. So this one, 9. Okay. Let's think about
Minus
9. It is
19.
9. Oh, let's go step by step. Plus -4 times corresponding element from row 2. What is the corresponding
7.
element? Very good. 7. So this is going to be 9 minus 7 fours are 28.
28.
So 9 minus 28 would be negative
Minus 19.
19, right? Okay. Let's think about the third element now. 10 plus -4 times what is the corresponding element in row 2?
3.
So
Will
this
be
will give me
minus 2.
10 minus
Minus
12,
2.
which is equal to -2. So these elements now I'm going to enter after the transformation. These elements have become like this. Are you all clear with this?
No.
Yes, sir.
Yes, sir.
You will have to do a lot of practice for this because we tend to make many mistakes while doing matrix transformation, which is quite common and which is okay. Unless you do practice, you won't become perfect in this. Fine. Even I might make a mistake while solving the problem. So now, can we move on to the next part?
Take -4 only, like
-4. Okay. You can take K can be anything, right? K should not be equal to 0. So
okay, anything else is fine.
yeah, anything else is allowed. Okay. Fine. Now, our main objective is to understand how to use this transformation. Okay. So let's move on to the next part. And one moment. Okay. So what is this problem? Transform A. So matrix can be denoted using a letter. So our matrix 3, 2, 6, 3. These are the elements of this matrix. We are calling that matrix as A. Okay. Transform this matrix into I. Oh, what is this I? Do you remember
New
what is this
name.
I? Identity matrix.
Identity matrix.
Identity matrix.
So what is the order of matrix A?
2 by 2.
2 by 2, correct?
2 by 2.
So how does a 2 by 2 identity matrix looks like?
1 0 0 1.
1 0
1 0 0 1 or
correct?
it
Correct.
can also be 0
Not
1
or,
1 0.
not or. It is 1 0 0 1. That's it. Okay. Identity matrix looks like this. So
why can't it be 0 1 1 0?
Oh, that's a definition, bacha. It is defined.
Okay.
The identity matrix is defined like this, right? So now our what are we trying to do? Transform A into I. So from A, I want to get to I. What does that mean? These elements 3, 2, 6, 3, I want to transform into 1 0 0 1 using ERT. What is ERT? Elementary row transformation. That's what we saw in the previous slide. Okay, elementary row transformation or elementary row operation. Okay, how are we going to do that? Very important. Please pay attention now. So let's first start by writing this original matrix 3, 2, 6, 3. Okay. Remember this sequence always. So the first thing we are going to do is try to make this element 1. Try to make this element 1. So this element refer to 3 in our problem, correct? Now tell me, using elementary row transformation, if I want to make this element 1, what operation should I perform?
Divide by 3
Divide by 3, absolutely correct, right?
or multiply by 1 by 3.
Yeah, multiply by 1 by 3. We can say divide by 3, which is fairly fine. Okay, so can I
So
say,
second one.
how am I going to write that? Row 1,
Row 1.
transform this by
So, but
multiplying
wait.
by 1 by 3 or whatever. If you want to write it like row 1 divided by 3, which is fine. Are you all okay with this notation now?
Sir, but like there is one better thing, right? We can, if we say subtract it by 2, then both of them will become 1
okay,
and
okay. 1 minute. Be careful. Did we do subtraction of any integer directly in any of this transformation? We have learned these 3 transformation. One, either you can swap the rows, or you can multiply all elements of a row by a constant, or this one. Did we do subtraction of constant directly from any of the elements or any of the rows?
No,
We
sir.
haven't. So these are the valid elementary row transformation. We can't use anything else. Very good, you raised this point. Okay, I hope everybody is clear. Now, so if we perform this on row 1, how row 1 is going to look like? What will happen to the first element?
1 and 2 by 3.
3 divided by 3 is 1. 2 divided by 3, oh, that will be 2 by 3, right? Don't worry about that. Let it be fraction, no problem. Have we done anything to our row 2? Not yet. So we can keep that as it is. Okay. So the first step is done. The second thing we got.
But I think we can do that. Do the same for row 2 also.
One minute. Let's go step by step. Now let's try to. This is our second step. I want to make this element 0. So you guys need to tell me now, how can I make this element 6 as 0? Yes. So first of all, multiply by 0.
It's not possible. K
Is
should
it
not
allowed?
equal to
Is it
0.
allowed?
No.
Is it allowed? Not allowed. Okay, so we can't do that.
Okay.
Then what else can we do?
Oh,
Can we say that?
We can
go ahead.
multiply the above row by 6 and subtract it.
Yes.
We can
So
have-
the advantage of making 1 here is we can multiply this 1 by 6 and then we can subtract that from this 6 so that this becomes 0. Are you
Sir,
all
I
with
did
me?
not get.
I will write down and then maybe it will make sense. See, I'm saying we want to make this 0. So we are trying to transform row 2. So I will start with row 2. What am I going to do? This row 2 from this value, I am going to subtract 6 times row 1. So if I multiply this 1 by 6, I will get 6. And if I subtract that 6 from this 6, what am I going to get? 0. Are you understanding? We can do this calculation
So,
separately.
but can't we just divide row 2 by 3 and make our calculations easier?
Uh,
But if we had row 2 by
if
3,
you
we will
don't
get-
follow the sequence, there are high chances you will go wrong. So you can try all these things.
sequence?
No. Like instead of this, not like the sequence thing, like we did R1 is equal to R1 by 3. So we can do the same first before this step. R2 is equal to R2 by 3.
You can do that if you want. You can do that if you want. Okay. So I'm not saying this is the only way to achieve this, but this is what I prefer to do. Okay, to avoid mistakes. Now let's do these calculations here. So first element of row 2, 6 will become what? 6 minus 6 times. What is the corresponding element of row 1? So this
1.
One.
Yeah, 1.
1, correct. So this is going to be 6 minus 6, that's equal to 0, correct? Let's also think about this, what this 3 will become. So 3 minus 6 times corresponding element of row 1. What is the corresponding element of row 1?
So 2 by 3.
2 by 3. Okay, 2 by 3.
So it will become 3 minus 4, that's minus
Yeah, so
1.
3 2s are
Minus
6 and 2 times 2
Minus
is 4. So
minus
this will
1.
become 3 minus 4. So this will become negative
Then
1,
we'll
correct?
multiply row 2 by minus
Oh,
1.
wait. Let's go step by step. So now let's write down this value in our matrix. So after transformation, what matrix are we getting now? First row, we didn't change anything, right? So it will stay as it is. Second row, we got this element 0, and we got here negative 1. Correct? Okay. Now step 2 is done. Then we attack this. We want to make this thing 1. That's my
So
step 3. What should I do now?
Multiply.
Just
Sir,
multiply
divide
by
by
minus
-1.
1. Multiply by -1, right?
Yeah.
So how am I going to
Yes.
write that? R3
R3 is equal to
minus 1
negative
into
1
R3.
times
minus
R3.
1.
Sir,
Agree? Yes, yes,
no,
yes.
sir. Shouldn't it be R2 because we are just considering row 2? There is
Oh,
no
I'm
row
sorry.
three.
I'm sorry. It's
Why?
Yeah,
not
it's R2. Sorry.
it's not 3, but 2. I'm sorry. Okay. So now look at this. We are not changing anything to row 1. So row 1 stay as it is. Row 2, first element, I'm multiplying that by -1. 0 times -1. 0 multiplied by anything is 0, right? So I don't have to worry about this. Okay. -1 into -1. Oh, that is 1. Very good. So now we got this as 1. So the last step is we have to make this element 0. And again, we do the same thing. We will use the row operation. We have this element as 1. So what should we do? Multiply
take,
this.
R1 will be equal to R1
let me write
minus
down.
1.
Let me write down.
Yeah, R1 equal to
Can I say?
R2.
So R1 we are
R1 would be
transforming
equal
Into
to
2 by
want to
3
make
minus
R1
R1
into 2 by
minus
3
2 by
into
3
third
R1.
of R2.
Yes.
R2, right? R2. Okay, let's go step by step. So first element, okay, 1.
We don't need to do for the first element.
Yeah, but let it be there. 2 by 3 into R2. What is R2? Corresponding element 0. Okay, 0. So this will give me 1 time 2/3 into 0 is 0. So 1 minus 0 is
1.
1.
It remains.
So our
the same.
this element did not change. Very important point. Okay, because that is what we want finally. Okay, what about this? 2 by 3 minus 2 by 3 times corresponding row 2 element, which is 1. So that's 2 by 3 minus 2 by 3. So we are subtracting two same numbers from each other. So the answer is going to be 0. Correct. Finally, what do we get? This 1
The identity.
is staying as
0,
1. This 2/3 has now become 0. And we didn't do anything with row 2 now. So 0, 1, and we achieved our objective. Yes, Kavin.
For the first row, when it was 3, 3, 2, and 6, 3, why can't we write it as plus on minus 2? We are not subtracting, we are adding plus on minus 2.
Oh, but then we in the operations which are allowed, is there anything where we are allowed to add or subtract constant directly? Only 3 operations are allowed. Okay, remember that. Therefore, we stick to this. Are you all clear about this?
Yes,
Sir, I have a doubt.
Yeah.
Sir, so K can be anything other than 0.
K can be anything other than 0, right?
I have a doubt.
Yes, Varun. Done. Okay. Anahita. Yes.
Yes, sir. So in the second last step, where we are like R1 will shift to R1 minus 2 by 3 R2. Is it
Yes.
necessary to do that operation on 1 when we know that it won't change after all?
See, once you become comfortable with these steps, I don't even expect you to write these things. If you are very good at calculation, you write the transformation, write the values directly. But
okay,
believe me, you guys will make a lot of mistakes when we actually solve the problem. So maybe it's wise to write these things initially till the time you become confident with that. Okay?
Yes.
Yes, Kavinan.
You said that we should follow a sequence. What is the sequence?
Yeah, the sequence is the left hand side top element, you make 1 first. That's my first step. So we made this, we turn this 3 into 1. Second, I'm saying element. So everything in this column, once you make this as 1, all other elements, you make it 0. So that is your next priority. So we wanted to make this 6 as 0, which we did. Next, then I'm saying in the row 2, you make this element as 1. So it was -1, we turn that into 1. And then the last step is this, make all other elements 0 of that column.
This 3 by 3 matrix, how the
Yeah, we'll solve problem, don't worry. Okay. Now, I want you guys to try one problem by yourself. Are you all okay with that?
Yes, sir.
Okay, very good.
Yes, sir.
Try this one by yourself. Okay. Okay, guys, I'll be back in a minute, so you can solve this question. Write down the steps. Don't skip any steps. Okay.
Sir, I'm done.
Okay, guys, I'm back.
Sir, I'm done. May I explain the procedure?
Yeah, sure. Go ahead. So let me first write down this.
Yeah.
Sir, can you?
Second one person to one.
Even I can tell.
Okay. So one step per person. Okay. So 1 minute.
Sir, can you wait for 2 minutes more? I'll just write it down quickly.
Okay, fine. Let's wait for 1 more minute and then we start. So I'm just writing the identity.
Yeah, I think
matrix.
4 people have raised hands, so 4 steps done.
Okay. So the
I've done it in 3 steps because one was automatically done.
Okay. Very good. Very good.
Yeah. Okay.
So 1 more minute and then we start. Okay. You are also done, Gayatri?
Yes, sir.
Okay, great. Okay, so let's get started now. Okay, so yes, Gayatri, can you help me with the first step? Let me just rewrite the matrix first. Okay, yes, Gayatri.
So, sir, we can write it as R1 will become 1/4 into R1.
1/4. Okay.
3 into R2.
Okay, 1 minute. So what are we aiming to do? First step, we are trying to make this element 1, right? Okay. So Gayatri said we divide all these first row by 4, right? That's what you said, Gayatri, correct?
Yes, sir.
Okay. Is there a better way? Is there a better way to do this?
Sir, -3 into R2, that gives us 3 steps.
-3. Okay. Anything else? Anything else? Do you see a 1 already in row 2?
I think you can do it.
Can we swap them?
Yes, sir, we can swap.
Yeah.
That's an easy thing, right, to do. So let's say if we do R1, if we swap R1 with R2, right? this is allowed, right? This is an acceptable transformation. What is it going to give me?
One,
First,
two, four,
second
7.
row will become first row. 1, 2, and 4, 7. Right? We got 1 here. Is this acceptable?
Yes.
Yeah, very good. Next step, I want to make this 0. That
Yeah,
means I want to
so
make
we can do
4, 0.
minus 4 R1.
Four
R2.
Minus-
into R1.
Okay, okay. So 1 minute, step by step. What are we going to change? Row 2. So start with that. Row 2.
2 will
Row
be
2 arrow,
equal to
row 2
R2
minus
2
4
minus
R1.
4 into R1.
R1.
Right?
Yes.
Okay. And I will
Yes,
write
sir.
down the step. Okay. So 4 will become 4 minus 4 times corresponding row element from 1, 1. So this is 4 minus 4. That's 0. How about this? 7 minus 4 times corresponding row element, which is 2. So that is 7 minus
1.
8. So this becomes -1, right? So I got my
Yes.
new elements, transformed elements. So let's rewrite this. The new
We can multiply last
1,
row
2,
by minus.
1 minute. Then we got 0 here, and then we got -1, right? Okay, the next step, I want to make this 1. So it's easy
Multiply by
thing.
minus 1.
Multiply row 2 by -1,
Minus
correct? So let me write down that row 2, we are going to transform it by multiplying by -1, correct?
We could
I'm not
also-
going to write down those steps. I will directly write down the transformed matrix because this is an easy step. First row, we are not changing anything. Second row, we are multiplying by -1. 0 multiplied by -1 doesn't make any difference. So 0. And -1 into -1 gives me +1. Correct? Okay. The last
So,
step, I want to make
yeah,
this
now
0.
we can write
Minus
R2
1
is
into
equal to
R1.
Okay.
into
but
R.
remember, you are changing which element? Element from row 1. So you
Row
should
one,
always
R1.
write R1.
1
What are you
is
trying to do?
equal to
R1
R1 minus
minus
2
2
times
into R2.
R2.
Very good, right? Okay, let's write down. So 1 minus 2 times corresponding row 2 element 0. Oh, so 2 into 0 is 0. So 1 minus 0, that's still going to remain as 1. What about this?
Change.
2 minus 2
Minus
times corresponding
1.
element from row 2, 1. So which is 2 minus 2, which is 0,
0.
right? So finally, we got what we were looking for. 1, 0, 0, 1.
So right,
Are you all comfortable?
Method.
Yeah, could be. See, as I said, there could be a different steps you will arrive at this. But is the logic clear to everybody? We opted for this simple step by swapping the rows because 1 was readily available there. Okay.
Sir, I don't think the order matters because I did the same steps with another order.
Yes, no
And
problem.
I don't think
No
it
problem.
matters.
Okay. Let's move on to the point which we are trying to understand how this thing is going to be useful to us. Okay, but before that, I want you to solve this system of equation using elimination. So if anybody having any doubt in the previous slide, please let me know. Otherwise, lower your hands, please.
Can you again explain the last step, sir? I went out accidentally because of power.
Which step?
So the last thing.
The last step. Okay. So see, we now have 1 here, 0 here, 1 here. So the only thing left is we want to make this 0, right? So what do? We multiply this row by 2 and subtract it from the row 1. So we are changing the element from row 1. So I start with row 1. What transformation I'm making? From this, I'm subtracting 2 into row 2. So 1 minus 2 times 0, which gives me 1 minus 0, 1. And 2 minus 2 times 1, which is 2 minus 2, again 0. And then finally, I got the identity matrix, which I'm looking for. Fine?
Yes, sir. Then you did something more.
No. That's it. Okay.
Thank you.
Now, yes, Neil and Dikshant, if you have any questions, quickly, or else lower your hands. Yeah. I want all of you to solve this system of equation for X and Y using elimination method.
So both are a part of one question only, right?
Yeah, two equations are there.
Yeah, there are two equations of one question, right? Or different
Yeah,
question?
yeah. So let's try to eliminate. Should we try this together maybe? Okay, let's try to eliminate x. So if I have to eliminate x, I have to make their coefficient same, but with opposite sign. So I'm going to multiply first by -3, let's say. So what operation I'm going to do? -3 times first equation plus I will multiply this by 2. Okay, +2 by and second equation. Okay, now let's say if I multiply this by -3, yeah, 1 minute, -3 into first equation, -6x, sorry, -15y, -69. Okay, second equation, we are adding these two. Second equation I'm multiplying by 2. So 6x, 8y, 48, right? And if we add this 6x minus 6x, I end up getting 0. Minus 15y plus 8y minus 7y minus 69 plus 48 negative 21. So basically we have -7y equal to -21. So y would be equal to
y is 3.
3, right?
Sir, and x is 4.
Yeah. Now substitute y equals to 3 in first equation. So you get 2x plus 5 times 3 equal to 23. So 2x plus 15 is equal to 23. So 2x equals to 23 minus 15, that's 8. Therefore x is equal to 4, right? So what is our solution?
So can we just subtract both these equations straight away? We get x minus y is equal to 1, and after
yes, you can do that. So you can, yes, you can even do that. So as I said, even for this there are many multiple ways you can handle this. Okay, yes.
Sir, I didn't understand what you did with the -3 into 1 plus 2.
Oh, so see, my objective, I wanted to eliminate x. How can I eliminate x? If I have a term with x having same coefficient but with different signs. So my objective was to have -6x and 6x, so that when I add them it becomes 0 and x is eliminated and I just get equation in terms of y. So for that I decided to multiply this by 3, not just 3 but by -3, so that this first element become -6x, and the second equation I decided to multiply by 2. So if I multiply this term by 2, I will get 6x, positive 6x, so that when I add them, they both become cancelled. They both become 0.
So this is elimination method.
Yeah. This is elimination. Yeah, yes, Shreya. Okay, everybody comfortable with this? Everybody comfortable with this?
Yes, sir.
Okay, now the interesting part. Look at this carefully. Okay.
Sir, this is Omkar.
Yes, Omkar.
Sir, we have last 2 or 3 minutes.
Okay, guys, I will have to extend this session with your permission. Those who are bored or tired, feel free to leave the session. But there are a couple of more things I want to cover, and I will need some time. And I hope you guys are fine to continue.
Yes, sir.
Yes.
No problem.
Okay. You guys need a 5 minutes break before we continue?
No, sir. No, sir.
If you need break, let me know. We can. Yes. No, you're fine. All are okay.
So by how much time will you extend?
Maybe another 15-20 minutes.
Okay, sir.
Yeah. Okay. So fine. Now the interesting part. Okay. Let me just erase this solution here from here. We know the solution is 4,3. Okay. Okay. These are my two equations, right? I'm just trying to convert them into a matrix form. Okay. So on the top, I'm writing this x and y, and then this RHS stands for right hand side. Okay, right hand side. And I'm going to put a line here just to differentiate between the variable x and y and the right hand side. Okay, first equation. Okay, the first equation. What is the coefficient of x?
2.
What is the coefficient of y?
5.
What do we have on the right hand side?
23.
Okay. Equation 2. What is the coefficient of x?
3.
What is the coefficient of y?
4.
Okay. And we have
24.
Sir, can we
24.
put a line like this in a matrix?
Oh, this is called an augmented matrix. This is called an augmented matrix. So a modified matrix. Okay. Fine. Now, are you all okay with this? So if I expand this, what will I get? 2x plus 5y is equal to 23. Okay, my first equation. If I expand the second row, 3x plus 4y
Y is 24.
is equal to 24. Are you all fine with this?
Yes.
Yeah.
Yes, sir.
Okay. Okay. Now the interesting part. See, what was the solution? We got
4,
x.
3.
Yeah. So can I say we got x equal to 4, right? And we got y is equal to 3, right? Look at this, x is equal to 4. Can I rewrite this as 1 time x
0
plus
and
0 time y, 0 time y is equal to 4. Are these two things same, this and this?
Yes, sir.
1 into x is
this
x,
into an identity
0 into
matrix.
y is 0 into
Zero.
y is 0, right? So these two things are same. Okay, fine,
Yeah.
no problem. Same way, can I write this as 0 times y plus 1
sir,
time y? 1 minute is equal to 3. Oh, sorry, this should be
Yeah.
x, my mistake. Yeah. So 0 times x is 0, 1 time y is y. And can I say this equation and this equation are same?
Yes, sir.
Yes,
Okay.
sir. So
Now
basically, we
let's-
have
we
to
can use
convert that
identity.
matrix into an identity.
Very good, very
Sir,
good. So
only
let's
the part on the left.
1 minute. Let me call this as equation A. Let me call this as equation B. Okay. Now the way we prepared this matrix, let's try to prepare another matrix for equation A and B. Okay. Okay. So again, x, y, and then we have right hand side. Fine. Then equation A. What is the coefficient of x?
So
What is the coefficient of x?
1 1 0
What is
0
the
1.
coefficient of y?
1
Zero.
0
0. What do we have on the right hand side?
4.
4
Okay. Let's think about equation B.
0
What is the coefficient of x?
0
0.
0
What is the
1
coefficient of y?
1.
what do
1
we have on the right hand side?
3.
3.
So do you guys see a identity matrix here?
Yes.
Yeah.
Right? What does that mean? If I start with this matrix and if I transform this into the identity matrix, whatever row operations I'm going to perform, I will keep doing that on the right hand side. Ultimately, I should get this as my answer. Are you understanding this relation now?
Can you
Yes.
again?
Yeah.
Sir,
Should
I
we-
didn't
should we-
understand
But I have a-
the relation.
Should we try solving this using this method?
Yes, sir.
Yes.
Yeah.
Yes.
Okay. So let's
Sir,
do
can
that.
you again explain this relation?
Sure. Look at this original matrix. Just focus on x and y values 2, 5, 3, 4, right? The final answer, what we got, x is equal to 4, y is equal to 3. We put that into modified equations where x and y both are there. And these two equations, I'm calling them A and B. When I put them in the matrix form, what am I getting? 1, 0, 0, 1. So isn't it an identity matrix?
Yes,
Is this
sir.
an identity matrix? If you just focus on this part, just forget about the right hand side. Just focus on this part. Isn't it an identity matrix? Right?
Yes.
So can I simply say, hey, if I want the solution for this system of equation, let me just transform this matrix to an identity matrix and I will get my answer. Are you understanding what I'm trying to say?
Yes, sir. Yes,
Right?
sir.
So let's try to do that. Let's use the next page. The same problem is there. What this method is called? It is called Gauss-Jordan elimination method. Okay, Gauss and Jordan, these two mathematicians, they discovered this method. So it is called Gauss-Jordan elimination method. Now let's try to do this together. Okay, I'm going to start with my original matrix. What is that? 2, 5,
2,
and I'm
5,
purposely
23.
drawing this line to show that this is our right hand side. Okay, then we have 3, 4, and 24, right? We are only going to focus on this part. This we want to convert into identity matrix. That means I'm looking for, okay, maybe I'll write down here short 1, 0, 0, 1. So I want to transform this into this. Okay, whatever happens to right hand side, we will keep changing that according to whatever transformations we are applying, right? So let's get started. What's the first step? We make this 1. What should I do? What transformation should I apply?
Divide by 2.
Very good. So we write R1 is equal to R1 divided by 2 or multiply by 1 by 2. Fine. Okay. Let's perform this operation and then what do we get? So we are changing the first row.
We get
right?
1
2 divided
5
by 2. That's 1. 5 divided by 2. 5 by 2.
5 by
2. And 23 divided by 2.
23 by 2.
Okay, fine. Have we done anything to row 2? No.
No.
So I'm going to write that as it is. 3,
Yes, sir.
4, and 24. Okay. What is the next step? I want to make this 0. You know how
Minus
to do
3
that.
into R1.
Correct.
Minus 3 into
R2, R2 minus 3 into R1. Correct?
Yeah.
So let's
Yes, sir.
write down that. Let's write down
R2 would
that.
be equal to R2 minus
R2
R1 into.
would be equal to R2 minus 3 times R1. And let's do this calculation step by step just to avoid mistakes. So 3 will become 3
1.
minus 3 times corresponding row 1 element, which
3
is
times
1.
1. So it is 0.
Correct. So this is 3 minus 3. That's equal to 0.
0.
Fine. Second element, 4 minus 3 times corresponding
5 by 2.
5 by 2. Okay. 5 by 2. So this is 5 3s are 15, 15 by 2. So 4 2s are 8.
Minus
8
3.
minus
So it comes
15.
minus 7 by 2.
Minus 7 by 2.
Yeah.
Yeah, minus 7 by 2. Okay, let's think about this. 24
Minus
minus 3 times.
23.
Minus 21 by 2.
So this will be how much? 23 times 3 is what? 69. Negative
Yes.
69. And 24 times 2 is 48.
48.
So 48 minus 69.
Minus
Minus
21 by
21 by 2,
Minus
right?
21 by 2. This is what
Minus
we
20.
got on
This is what we got there, right? Correct.
because
So let's
this is the
write
same
down
thing
this.
that we did.
Yes. I agree. So let's write down this. Okay. New matrix. We didn't do anything with row 1. So row 1 stay as it is.
Sir, you said we got this somewhere. So where did we?
Oh, in the previous.
We are doing
21,
elimination.
You remember that we got this 21
Yes,
here.
sir. Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. Second row will become 0. First element. Second element negative 7 by 2. Oh, sorry. Negative 7 by 2. Third element negative 21 by 2.
Sir, now we
Okay.
can multiply it by minus 2 by 7.
Yeah,
Second
we
row.
want to make this 1. So we can multiply by minus 2 by 7, right? Take the reciprocal of this and multiply. Okay. So let me write down. Maybe you can use this space. So the operation that we want to do is row 2. We are going to multiply that by negative 2 by 7. Agree?
Yeah.
Yes, sir.
So now Okay, let's write down this step directly. First row, I'm not changing anything. 1, 5 by 2, 23 by 2. 0 into negative 2 by 7. Oh, we still
Zero.
end up getting 0.
No.
Minus
then
7 by
we
2
would
into
get to
minus 2
one.
by 7,
One.
we get 1. Minus 21 by 2 into this. Okay,
Would be
maybe
three.
if you want, we can just write down this minus 21
be
by
three.
2 as a part of rough calculation. We can do that. Minus 2 by 7.
Two
So
cancel.
negative negative will get cancelled. This will get cancelled. 7 3s are 21. We get 3.
Three.
Right? Okay. The last part. I want to make this
We
0.
already got the y solution.
Yes.
Yes, sir.
Yes.
I is equal
Okay.
to
So we want to make this 0. I'm changing something in row
R1.
1. I'm going to write row 1 is equal to row 1 minus
minus
5 by 2
5 by 2
Into
of
row
R2.
right? Okay, very good. So let's do this now. 1 into 5 by 2 times 0. 5 by 2 times 0 is 0. So 1 minus 0, that's just 1. Okay. 5 by 2 minus 5 by 2 into 1. 5 by 2 into 1 is 5 by 2. So 5 by 2
Zero.
minus 5 by 2 will
Zero.
become 0. Okay, we have to be a little careful here. So maybe I'll write down this
23 by 2.
7 by 2.
minus
Yeah, it comes.
5 by 2 times 3, right? So this is nothing but
So it will come
23
8 by 2.
2 minus 5 times 3,
15 by 2.
15 by 2. So
Which is
23
equal to
minus
8
15,
by
we have the
2
same
or
denominator.
4.
8 by 2, which is nothing but
4.
right? So we got this as 4. Okay.
Have not done any change to our
Then we have, yeah, so 0, 1, 3.
0, 1,
1,
and 3.
Now
So x is
remember
equal to
what
4,
we
y is equal to 3.
correct. Remember this matrix when we initially formed, what was there? X, Y, and RHS, right? So the first row is telling me 1 time X plus 0 time Y is equal to 4, and which is simply nothing but X is equal to 4, right? The second row is telling me 0 time X plus 1 time Y is equal to 3, which is simply nothing but Y is equal to 3. Once you understand this, you can easily see you have a 1 here. So this is X is equal to 4. You have a 1 here. This is Y is equal to 3. Have you now understood how can we solve simultaneous equations using matrices? Are you all clear about this?
Yes, sir. But the elimination was still easy.
Yeah, you might feel that elimination is easy. I agree. But
Elimination is less time taking.
Yes, it is less time taking. I completely
For
agree.
some problems,
But
this would
when,
be-
yes, but when it comes to computer solving the equation, this is what is used in the background. Okay, the matrices. And think of system where there are many equations, and then it's difficult for us to solve using this manual method, and then this comes very handy. Okay. Yes, Parul.
Sir, I think we can, using this, we can solve it for how many ever variables there are, we can get.
Absolutely correct. Absolutely correct. Absolutely correct. Right. Yes, Kavina.
Sir, can you move to previous slide one?
Sure.
Yes, like for solving for solving with 3 variables, we need 3 equations, and again
Absolutely
we can do
correct.
the same.
So what kind of matrix are we going to get in that case? It will be a 3 by 3 matrix, correct?
3 by 3 matrix.
And then the identity matrix will look like 1,
1,
0,
0,
0, 0, 1, 0, 0, 0, 0,
1.
Right? So what sequence you should follow? Please remember this, very important. First thing is this, you will make this one. Then you try to make both the elements of this column to be 0. Okay, once you are done with this, move to this. Make this one. Oh, maybe in 2 steps, maybe in 2 different steps. We can do that in 1 step. Okay, but because when you are going to transform this row and this row, what are you going to do? Let's assume in this original matrix, I'm not talking about whatever elements are there. Let's forget about them. Let's say you have 4 here and you have 5 here. So what are you going to do to make this 0? You will say R2 will be R2 minus 4 times R1. Correct?
Yes,
right?
Sir,
Because
yes, sir,
you
I
have
get
1
it.
here already. R3 is equal to R3 minus 5 times R1. Right? You can perform these two steps together if you want, and you can make this 0. If you're not comfortable, go one by one. Are you understanding the logic now?
Yes, sir.
By making
Yes,
this 1, we take advantage of that 1 and try to make these zeros. Okay, fine.
The next column. What about the next two columns?
What? Yeah, the same. Yeah. So then the next target should be, you should make this 1, and then after this is 1, try to make these 2 zeros, and the last step, make this 1 and try to make these 2 zeros.
First one, we should do the 1, then to 0.
Yes, 1, then handle this column, make everything else 0. Then this one, handle this column, make all other elements 0. Then move to the third column, make this 1 and make rest of the elements 0. Fine.
And you said we will use determinant here. What is it?
Determinant we are not going to do. Determinant is basically finding the value of that matrix. We don't need that, so I'm not going to get into that. Okay, matrix itself is a very vast topic. Okay, I'm just trying to focus on the part which we need for this solving equation. That's it.
When I asked to my teacher, he said that we should know about determinant and all those things. Then only we can solve it in 3 variables. Yeah.
Not really necessary. 1 minute. See, for example, the next example which I wanted you to solve is with 3 variables and 3 equations. So I don't know if you guys are interested, we can do that now, or I can add this to homework.
Can you give it as homework?
So we can do one problem now and then other 2 will do it.
Okay. So let's do one thing. 1 minute. See, this is what I have for you guys in the homework. I have added one problem for elementary transformation into I. Then one problem with 2 equations, one problem with 3 equations. Okay, this will be in the homework. But now I'm saying those who still have energy and want to solve this problem of 3 equations, 3 variable, they can stay back. Those who are tired, feel free to leave. No problem. Okay. So is there anyone who wants to stay back? Kaveen said that he want to try. So
Sir, I have a doubt.
Yes, sir, I will.
Okay, so those who want to stay back, they can stay. Okay, wait. Is there any Omkar and Sriram? Do you want to give any instruction to these guys, or those who are done, can they leave?
No, I wanted to take a picture with you and everyone.
Oh, okay. But then some people have already left, I believe. I don't know. There are only 26 participants.
Yeah.
So you can take a photo with everyone, those who are at least available, if you're okay with that, Sriram.
Or we can also do it next time.
Or maybe we can do that in tomorrow's session.
Yeah, we can do it next time.
Yeah. Is that okay? With tomorrow's session, yeah, let's do that in tomorrow's session. And now those who want to leave, those who are tired, they can leave. Those who want to stay back, we will stay back and try solving this question together. Okay. Or you want to try by yourself? Those who are staying back, do you want to try yourself, or we do together?
We want to try ourselves.
You want to try yourself? Okay. Fine. Go ahead. So I will also start writing.
Sir, I have a question.
Yeah, question. Go ahead.
Yes, sir. So you said using matrices is easier for computers, but then like why is it easy for computers? Because at the end we are just using the reasoning that we use to solve equations is what I think. Correct, you have to multiply this, then subtract that.
I agree. So Urvi, if I give you, let's say 10 equations having 10 variables, what do you think? How easy it will be to solve using this elimination method, which we use generally in school?
Won't it be the same thing with this matrix as well? Because you have to do the same kind of reasoning, right?
I'm not saying the method, the logic is going to be the same. I agree with you. But then which method would be more efficient? Solving that with our normal elimination method, this one will be easier, or maybe solving with matrices would be easier. See, for computers, it's just a matter of you give a set of instructions and then it's an iterative process which computer will keep on doing.
Yeah.
Right. So see, whenever we are thinking about computer, please don't think of smaller problems. Why? Computers are there to handle complex problems, right? Many equations which we cannot do manually, or we can do, but it will take a lot of time. Correct. So for those things, this using matrix would be much easier. Okay, so let's try to do this. I will we have to use Gauss-Jordan elimination method, okay, that matrix transformation. So the very first thing on the corner, yes, Parul, do you have questions?
Yes. No, you
yeah,
called
go
it
ahead.
some augmented matrix.
Augmented matrix, yes.
Can you spell
Because
it?
yeah, because oh, you want me to spell it?
No, can you write it? Yeah.
Oh yeah, sure.
Okay.
Yeah. Okay. Now this is going to be a 3 by 3 matrix, right? Because we have 3 variables, 3 equations. So finally, what I'm aiming to achieve is this 1 0 0 0 1 0 and 0 0 1. So always remember that. Okay. Now let's write down this matrix. Those who are there, they can start on their
1
own.
1 minus 1.
Yeah.
7.
1 minute. So first is 1 negative 1. Please, very important. Z, negative Z is there. That means negative 1 is the coefficient. Remember that. Okay. The right hand side, we have 7.
Sir, I got confused. Actually, if there isn't any variable, we should take it as 1, right?
1, yes. So there is nothing, that means we are multiplying by 1, right?
Yeah.
Okay. So second row, 1
minus
negative
1 2.
Positive 2 and 3.
Sir, and
Third one, yeah.
if there are 2 equations with 3 variable and 1 equation with 2 variable, we should take the 2 variable equation as 0.
We will talk about that maybe little later, maybe in tomorrow's session. Yeah. Okay. So 2 1 and 1 and this is 9. Okay, this is my initial matrix. Okay, now let's start. We want to make the first element on the left hand top corner 1. Oh, that's already 1. I don't have to worry about that.
So we have to make the rest.
Time
of
is already up. So as I said, those who want to leave, feel free to leave, no problem. Those who want to stay back, we will solve this problem and then we will end the session.
I was enjoying this class so much, I didn't even notice the clock.
Yeah, but I can understand some of you might have got tired. It's almost 2 hours now. So please feel free to leave the session if you are tired. Okay.
So now we could subtract the.
Yeah. So
subtract
the next objective, let's try to make this 0 and this 0. Should we do that simultaneously? Or should we go step by step? Simultaneously?
Simultaneously.
Okay. Let me write down for row 2. What do I need to do?
Row.
We already have 1.
Row 2 minus row 1.
Simply row 2 minus row 1, right? That's it.
Yeah.
Correct?
Yeah.
Okay. For row 3.
Row 1 into
row 3.
Row
3
minus row 1 plus row 2.
Row 1.
No. 2 times row 1.
Okay.
Correct. We have a 2 here, right? So if I multiply, we should always stick to this row as a reference one. Okay, I'm using R1 here everywhere. Okay, fine, clear. Let's try to transform this now.
Yeah.
Are we changing anything in the first row?
No.
So it will stay as it is. 1 1 negative 1 7. Okay, row 2. What are we doing? From row 2 element, we are subtracting row 1. So very careful. 1 minus 1 0. Minus 1 minus 1. That will become
2.
minus 2. Very good. 2 minus 1.
2 plus 1, which
That is
3.
3. Very good. 3 minus 7.
Minus 4.
Very good. Minus 4. Okay, let's think about row 3. Row 3 minus 2 times R1. So 2 minus 2 times 1. 2 times 1 is 2. Minus 2.
0.
0.
1 minus 2 times 1. 2 times 1 is 2. 1 minus 2.
Minus 1.
Minus 1.
1 minus 2 times negative 1. So 2 times negative 1 is negative 2.
Plus
and 1 minus
plus
negative
2,
2
basically
is 1 plus
3.
2, which is 3.
3.
Okay. 9 minus 2 times 7.
9
2
minus
times 7
14.
is 14. 9 minus 14 is
5.
Minus
Minus 5.
right. Are you all with me until here?
Yes, sir.
Everybody clear?
Now we
Okay.
do the second row.
Yeah.
We have to convert that minus 2 as plus 1.
Get this one. Get this one. Okay. What do? We divide row 2 by
Minus 1 by 2.
yeah, or multiply by minus 1 by 2 or divide by negative 2. Okay, let's do that one operation first. Okay, only that one operation. So I'm saying row 2 is equal to row 2
Row 2 by 2.
The value of
Minus
Z.
2.
Minus 2.
1 minute. So
Row 1 remains the same.
row 1 remains the same, 1, 1, minus 1, and then we have 7. 0 divided by minus 2, it will still remain 0. Negative 2 divided by negative 2 becomes 1. 3 divided by minus 2, minus 3 by 2.
Minus 3 by 2.
Minus 4 divided by minus 2,
2 will be 2.
positive 2, right?
Yes.
Okay. The last row, we are not doing anything. So that will stay as it is. 0, negative 1, 3, negative 5. Right? What's the next objective? We want to make this 0 and this 0.
And this 0.
Right? So let's think about R1. Tell me what should be, and reference should be always R2. Okay. So R1, what are we going to do with R1?
Minus
Subtract
R2.
R2 from that, correct?
Yeah.
Because we already have 1 here. So R1 minus R2, right? What are we going to do with R3?
Plus
Reference
R2.
plus R2, because we have negative 1. Negative 1 plus 1 will make this 0, correct?
Yes,
So
sir.
R3 will be R3 plus R2. Okay, let's do the transformation now. First row, are we changing anything?
No.
No.
Yes.
I will.
Yes.
Oh, we are not. Oh, sorry. We are changing. R1 minus R2. So 1 minus 0?
1.
1.
1.
1 minus 1?
0.
0.
Minus 1 minus 3 by 2. 1 minute. Let's write down this.
Minus 1 by
Minus
2.
1 minus 3 by 2.
Well,
Which
you
is
can plus.
nothing but minus 1 plus 3 by 2. So
Some 5
what
by
is going to be this?
Minus 4.
What 5 by 2? This is
No, it
minus
will be
2 plus
half.
3.
Okay.
Right? So positive 1 by 2, right?
1 by 2.
Agree, everybody?
Yes, sir.
Yeah, positive 1 by 2. Okay. Let's think about this. R1 minus R2. 7 minus 2. What is 7 minus 2?
5.
5. Okay. Row 2, we are not changing anything. Let's write down as it is. 0, 1, negative 3 by 2, and 2. Okay. Row 3, we are doing R3 plus R2. So 0 plus 0, 0.
0.
Minus 1 plus 1,
0.
0.
0. 3 plus minus 3 by 2. Oh, okay, wait. Let's write down this. 3 plus minus 3 by 2. So that's nothing but 3
by
minus
2.
3 by 2. So 3 to the 6, 6 minus 3, 3 by 2, right? Positive 3 by 2.
Yes.
Okay. Positive 3 by 2. What happens to this? Minus 5 plus 2.
Minus 3.
So this becomes minus 3. Okay. We are done with second column as well. The next step, let's make this one.
R3.
Become R3 will be equal to
Multiply by 2 by 3.
2 by
right?
3.
Row 3, we have to multiply by 2 by 3. Let's do that transformation first, only first transformation. So I'm going to do R3 equal to 2 by 3 times R3. Okay, let's write down the new matrix.
R1, R2 remains the same.
Yeah, R1, R2. So let me first copy 1, 0, 1 by 2 and 5. R2 is 0, 1, negative 3 by 2 and 2. The last one, oh, we are multiplying by 2 by 3. 0 into 2 by 3, 0. 0 into 2 by 3, 0. 3 by 2 into 2 by 3, 1. And negative 3 into 2 by 3. Okay, let me write down. Negative 3 times 2 by 3.
That will be
So
when 3 gets cancelled, it becomes
negative
minus
2.
2.
Yeah, minus 2. Okay,
For the
fine.
solution for the
Yeah,
third.
the last one. Yeah. Correct. Now let's try to make these two elements 0. Okay. So let's think about R1. What transformation should I do?
Minus 1 by 2.
Correct.
No.
R1.
R1
Correct.
minus R3
half of R3.
into 2.
Right?
Into 1 by 2. Yeah.
Okay. What about R2? It's already negative 3 by 2. So
2 minus
R2 plus. It's already negative,
Okay.
right? Plus 3 by 2 times R3. We are taking reference of row 3. Remember, we converted this into 1. So we have to use that always. Okay. Therefore, I'm taking R3. Okay. Now we have to be little careful. R1. Okay. Let's try to write down this. We are doing R1 minus half of R3. R1 minus half of R3. 1 minus half of 0. Half of 0 is 0. 1 minus 0 is 0. Oh, sorry. 1. Okay. Then 0 minus half of 0. Oh, half of 0 is 0. And 0 minus 0, 0. Nothing has changed. Half minus half of 1. Half of 1 is
Minus
half.
half.
Half minus half is 0.
0.
Right? Correct. Okay. 5 minus half of -2. 1 minute. Let me write
5
down.
plus
5
1.
minus half of, that is 1/2 times, oh, just half, not negative, times -2, right? So this will become -1
Minus.
and minus will become plus. So can I say this will become 5 plus 1, 6?
Yes, sir.
Agree?
Yes, sir.
Okay, this is 6. Fine. Row 2. Row 2 plus 3/2 R3. 0 plus 3/2 of 0. Oh, that's 0.
Zero.
And 0 plus 0, 0. What about this? 1 plus 3/2 of 0. 3/2 of 0 is 0. And 1 plus 0, 1.
1.
Okay, -3/2 plus 3/2 of 1. 3/2 of 1 is 3/2. -3/2
Zero.
plus 3/2 will become
Zero.
0. 2 plus 3/2 of -2. Okay, let's be careful here. 2
minus 1.
plus,
minus 1.
Minus
yeah,
1.
3/2 of -2.
2
So
cancel.
this will become -1, -3. 2 minus 3,
Minus 1.
-1. Okay, we got -1.
R-
Last row we didn't change anything. So 0, 0, 1 and
We're done.
-2. What does this tell you? X is equal to 6.
5.
Y
Y
is
is
equal
equal
to
to
Y is
minus
equal to
1.
-1.
So Y is equal to -1 and Z is
Z
equal to
is
minus
equal
1.
to minus 2.
And
And
what
there was
should we do?
solution.
We should check. We should check that. Okay. So
I've
let's
already
substitute
checked,
this in
sir.
the, you check. So let's check. First equation will become 6. Y is -1. Z minus, okay. So this will become
6 minus 1 plus 2, which should be
6 minus 1 is 5. 5 plus 2, 7. Yes, that's correct. Should we check the second one just to be on safe side? Okay. 6 minus y minus 1. So that becomes +1. 6 plus 1, 7. And then 2 times 2 is 4, but -4.
So
So
7 minus
minus
4.
4,
Yeah,
3.
that's
Very good. Let's check the last one. 2 times 6, 12. Plus y, so -1. 12 minus
11.
1, 11. And then we have minus plus z, which is
9.
-2. So
Minus 2.
my 11
9.
minus 2,
9.
9. Right?
Yes,
Are
sir.
you guys clear with this now?
Yes, sir.
Yes, yes.
Very good. Very good. So thank you so much for your patience and staying back for almost half an hour extra. We will end this session here.
Sir, it was
And,
really, I mean, it was
Yes, sir. This method was really interesting.
interesting, right?
Yes.
Yeah. Yes.
So 1 minute
Yes.
will go.
Yes.
Sir,
Yeah.
but
So yes. Yes.
how is this like, I wouldn't say related, but where is it used in linear programming?
We'll come to that. So see, you guys should understand this. If you understand this, then only you will understand the simplex method. And that's the reason I'm spending so much of time on all these things. Okay. So
Okay,
have
sir.
patience. You will understand. You'll realize that tomorrow. Okay.
Okay, sir. Thank you.
Yeah. Yeah.
Thank you,
Yeah.
sir.
Sir,
Thank you,
sir,
sir.
just one thing I wanted to ask, sir.
Yeah.
Sir, like I understood everything, but just one problem I'm facing, like, usually when I'm trying to solve, that time I don't know, like, which one, like, now I should make this.
Okay. Which one should I make 0? Okay. So as I
No, sir,
said,
no, I know that the like
the
it should
sequence, you know, right?
sequence I know. Yeah, but I
Then-
don't know that like next step, this is what should be done.
Oh, this is what the step I should do. You're not sure about that. What step should I do? Right?
Yeah. Like I can approach it in so many ways. Which one will be suitable?
Correct. So see, when we talk about that sequence, the important point is making some element 1, not some element, but let's talk about it again. So first you always make this 1, right? Once
Okay,
you
sir.
make this 1, for the next step, you are going to make use of this 1 and try to make these 2 zeros. So coming back to this is our original equation. We already have 1 here, right?
Yes, sir.
Now, since I already have 1 here, my task is to make these 2 0. Okay,
Using
that
the
means
1.
I'm going to, using this 1. So now I'm going to transform this element. So I am going to do something with row 2. So I start with writing row 2. And then this element is already 1. So if I simply subtract the row 1 from that, I will be able to make this 0, right? Remember, you have to use this
Yes, sir.
1. So you have to use row 1. So what
Okay.
what I wrote here, row 2 minus row 1. Okay, we are done with R2. R3. If I want to use this 1 and make this 0, what operation should I do?
Yes, sir.
I'm going to start with R3 and then I must multiply this 1 by this number, which is 2, and subtract, right? Making
yes,
sense?
yes.
Okay, let's look at the second one. We then turn this into 1. We have done that here, right? We turn this
Yes,
into
sir.
1. Or rather here. Okay, here we did that 1. Now using this 1, I want to turn this into 0 and this into 0.
Okay.
So what did I do? I'm changing R1. So I started with R1. Okay. And this is already 1. So if I subtract this 1 from it, I'm done. So what operation did I write? R1 minus R2.
Minus R2. Okay.
Okay.
Yes.
What about this? Here I already have -1. So I don't need to subtract. I just need to add 1 to that, right?
Okay.
So I'm saying R3 is R3 plus R2. Everywhere I'm using reference as R2, which we have already turned into 1. Everywhere I'm using reference as R1, which I have already turned into 1. And when it comes to the last step, we converted this into 1. Oh, not this one. I'm sorry. This into 1.
Yeah.
Okay. And we want to use this to make these two guys 0. So
0.
R1. I start with R1. If I want to make this 0, I have to subtract -1 by 2.
Yeah.
For that, I will multiply this by 1 by 2.
1 by 2. Okay.
So that is what we have done here.
Yeah.
What about this? If I want to make this 0, I should add 3 by 2.
Yeah.
Using this. So I have to multiply this by 3
Multiply
by
it
2.
with 3
That's
by
what we have done. Is it now clear?
Yeah. So I think the more questions are solved will come naturally.
Yes, it needs a lot of practice because these are very confusing problems. Many people even struggle in grade 11 and 12. They make a lot of mistakes. You guys are very young and learning this at a young age. So yes, it will need practice, definitely. Okay. So my suggestion would be solve all the problems which we have solved in the class first, and then try to attempt the homework questions. And in fact, you guys did something in homework of yesterday, right? These questions. These also, you know the solution already by elimination method.
Yes, sir.
You can try
Yes,
even
sir.
solving this by Gauss and Jordan elimination method. Okay, for practice, those who are interested.
Sir,
Okay. Yes.
I have an idea. Can you show me that question? Just a sec.
Which one? This one?
This question we solved now.
Yeah, this one.
So we have 1 over here and one over here in the center.
Yeah.
Can we take this this here so that this the one will already be over here, so that will satisfy this condition?
Oh, but then see.
Can we write this as the first thing?
Yeah, you can do that. You can do that. So you are saying we should swap row 2, row 3.
Without swapping it after writing here, we can just swap it here itself.
Oh, but then see, first step, you just transform this data into a matrix without changing their order.
Okay.
You are saying you want to consider this as equation 3 and this as equation 2. You can do that. You can do that because these are 3 equations. You can write them in any order. Yeah, you can do that. No problem. You can do that.
So that will
Even
reduce.
Yes.
I had an idea like in step 2, where it is in the second column, it is 1 minus 2 and minus 1. We can swap rows. Can we swap rows 1 and
okay. So these 2 rows you are saying we can swap?
Yes, sir. I did not.
Yeah,
do
we can
because
do that. We can do that. But making this 1 is not a big task, right? You just multiply this by -½ and you are done. You can do that. See, as I said, there are multiple ways you can arrive at the final identity matrix. Okay, so yes, you can try different things. Definitely. Okay, guys. So,
thank you, sir.
Good job. Thank you so much for your patience.
so much,
and see you
sir.
again. If
Thank you
anyone
so
interested
much.
can join the
Enjoyed
web
the
session in the
session.
evening. Okay.
Thank you so much, sir. Bye, sir.
Yeah, bye. Yes, Kavinayan, any doubt? Yeah.
Sir, even if there is 4 variables, first we should we should change the 1, then 3 zeros. Then next column 1 0.
Next column 1, 3 zeros. Next column 1, 3 zeros. Next column 1, 3 zeros. Yes, that's the sequence. Absolutely correct.
Okay.
Yeah.
Okay. First 1,
So
then
there
0.
is,
Yes. Yes. Sorry.
so there is no evening session today, right?
Well, only help session is there for half an hour. I guess 6 to 6:30.
No,
Not for you guys. I
Yogesh
don't
sir,
know.
that is for batch B.
Oh, not for
For
these guys.
batch A, we have tomorrow.
Okay. Okay. No problem. No problem. Sorry, guys. I didn't know that. Okay, fine. Thank you, Sriram and Omkar as well for your patience and allowing me to extend my session by half an hour. Thanks a lot.
Thank you, sir. Bye, sir.
Yeah.
Thank
Bye,
you, sir.
everyone.
Thank you, sir.
See you
Bye.
tomorrow.
Session.
Yeah. Bye. Bye. Yes.